Good evening, Ananda. Uh, Now we will discuss about the degrees of freedom, how to determine the degrees of freedom for the given mechanism. For example, a 6 bar mechanism is given to you like this. So this is a mechanism which consists of 6 links, number of links 6. For this, how to determine the mobility or degrees of freedom using Kurzbach criterion. If we observe the formula for this, the degrees of freedom DOF is equal to DOF, that is equal to 3 into number of links minus 1 minus 2 into J. J means joints. Only binary joints we have to consider. Anyway, minus H is there. H means higher pace. H is equal to higher pace. If we observe the diagram, the 6 bar mechanism, there is no higher pair. So then, anyway, links are there. So number of links L is equal to 6 directly we can see. And we have to calculate the binary joints, number of binary joints. J is equal to, see here, so this is 1, here 2, here 3, this is 4, this is 5, and this is 6, this is 7. Total 7 number of binary joints are there. Binary joint means if two links are there at a joint, then we call it as a binary joint. For example, it is a joint. Here, two links like this. Now it is a binary joint. For example, at a joint, if 3 links are there like this, then we have to consider it as a 3 minus 1, that is equal to 2 binary joints. For example, if 4 links are there at a joint, then we can consider 4 minus 1 equal to 3 number of binary joints. Binary joints. Like this, we have to calculate. It means generalized formula. If n number of links are there at a single joint, then we have to consider n minus 1 number of binary joints. We have to calculate like this. So, while calculating in this formula, DOF is equal to 3 into number of links minus 1 minus 2 into joints, then these joints we have to consider only binary joints. So in this diagram, in this 6 bar mechanism, all are binary joints. If you see at each joint only two links are there. Here 1, 2, 3, 4, 5, 6, 7. So if we observe any joint, at each joint we have only two links. So for that reason we are considering all these all these joints as a binary joints. Total number 7. 7. And no higher pairs. So if I substitute these values in the formula, then I will get DOF is equal to 3 into links minus 1, that is 6 minus 1, minus 2 into binary joint 7, that is equal to 3 into 5, 15 minus 14, that is equal to 1. 1 is the degrees of freedom for the given 6 bar mechanism. And I can find out by using one more formula is there to find out degrees of freedom for a mechanism. That is, say, I'll write here. Degrees of freedom is equal to This is one more formula. Number of links minus 2 into number of loops, 2 into number of loops plus 1. This is another formula. So by using this formula, you know already for the 6 bar mechanism, number of links total 6 links. So 6 minus 2 into number of loops means you see this gap here. This is one loop and this is another loop. So it means here two loops are there. 2 into 2 plus 1. That is equal to 6 minus 4 plus 1, 5. That is equal to 1. Degrees of freedom, one same answer here and here. It means we can determine the degrees of freedom for a given mechanism by using this formula, Kurzbach criterion, and by using this formula. So in both the formulas, we are getting the same answer. For example, you see we have another mechanism here. You see here. So here number of links L is equal to total count 8. L is equal to 8. And if you see the joints I will calculate how many joints are there. See here, first I'll check edges. So this is one edge. I think it is 1, for example, 1. And this is number 2. This is number 3. And here, if you observe here at this joint, I have 3 links. This is one link, and link. This is a link 3, link 6, and a link 5. 3 links are there. I told you already, if 3 links are there at a single joint, then we have to consider it as a 2 number of binary joints. It means here joint number 1, 2, 3, and here 2 joints are there. It means 3, 4, comma 5 here. 4, comma 5. Next here also same. 3 joints are there. 1, 2, 3. It means here 6, comma 7. Comma 7. And here one more joint. Only 2 links are there. It is 8. And here this is a 9. Only 2 links are there at this joint. And 9. This is also, this is 10. And this is 11. So total 11 number of binary joints there. So then I can find out the degrees of freedom by using this formula. DOF is equal to 3 into L minus 1. It means 8 minus 1 minus 2Z, 2 into 11. No higher pace. It means 3 into 7 minus 2 into 11. That is equal to 21 minus 22. It means minus 1 is the degrees of freedom for this mechanism. If I find out the degrees of freedom by using this formula, loops, now I will calculate how many loops are there here. Gaps, you see, we identify the gaps. Here 1, 2, 3, 4. 4 loops are there. So loops here 4. Now DOF, as per the DOF equation, DOF is equal to number of links, that is 8, minus 2 into number of loops, 4, plus 1. That is equal to 8 minus 2 fours are 8 plus 1, 9. That is equal to minus 1. Again we get the same answer. So this is the way of finding out the degrees of freedom for the given mechanism. Using Kurzbach criterion, two equations are there. Using those two equations, we can determine and we will get the same answer.